está.
Okay, so for the ones that don't know me, my name is María Leyva, and I am doing a master thesis here with Petia, and I'm going to talk to you a little bit what am I doing and what do I have left to do. So for my master thesis, my main objective, of course, is finishing the master's, and then afterwards, I intend to do scene recognition for food-related environments, both for normal images or not egocentric images, and for egocentric images. I am working with two data sets. The first of them is Places 365. It is quite known, it is huge, it is labeled, and it is very well known, so there are many models already pertaining on it, and there are a lot of papers and a lot of proposals and a lot of information. And the second dataset I'm using is called EcoPlaces, and it is ecocentric images labeled for food-related and not food-related environments. It started from the dataset this university had, the EDUB set, and I increased it, wearing the camera myself and labeling other photographs you had available from your own gatherings for your own problems. And it is manually labeled, and yesterday, I still have some photos to upload and label. We have over 60,000 images, and 23,000 of them were food related. Honestly, to gather the images at the end, I cheated a little bit because I only wore the camera for food-related environment because I was very tired of labeling not food-related environments, and I needed to increase it. As you see, the images are quite different. They both belong to the class fast food restaurant. The first one is from Places, and you see that it is a very nice image trying to capture all the information in the restaurant. It is well illuminated, it has a wide range of view, it is clean and it is empty, we haven't got anything. And the second one is my own image, where you can see basically my head. And it is also a fast food restaurant, and you can tell it because of the fries, not much else. So what am I doing? What am I using? I'm using Cafe with Python, basically, and I am using BGG16 as the main architecture. I chose this one because this one was the best basic architecture getting for the Places 365 dataset. It is not very big, so it doesn't take a lot of time to train, nor it occupies a lot of memory. For instance, ResNet had a more or less similar results, but it is bigger, slower, and it occupies much more memory. So we decided to stay with BGG16. And as baseline, I'm using the results on the model trained only on Places 365 and checking the hits for the classes I am interested in, that are the food-related ones. And I am doing a simple fine-tuning with the images belonging to the classes I am interested in. So what are my work lines? First was increasing EcoPlaces, because if I don't have images, I can't do anything. And then I have to calculate the baseline, the accuracy of Places 365, only on the food-related classes. And they also had one net called hybrid BGG that used Places 365 and ImageNet and outputs 1,365 labels. So I have to add a SVM classifier here to see how it performs in our image. In the paper of them, they showed that this was the model that generalizes the best for other datasets. So it is interesting to take it into account. And also I have to take into account the baseline for EcoPlaces with a BGG trained only on Places 365 and with BGG fine-tuned for food-related environments. And from that, I have to improve the results. Now I am focused in negative weight decorrelations, that is trying to force the network to learn weight vectors that are orthogonal among them, so between them, so that each healing unit learns the biggest amount of information and there aren't redundancies. It is very interesting. There is a paper with a lot of details and explaining the procedure, but the problem I'm facing right now is that it is very slow because I have to deal with the weight matrices that are quite big in each iteration, so it slows the training a little bit. For solving the lack of images, I am considering the class merging by extracting info from the confusion matrix of places, seeing which classes are the most confused and therefore the most similar. And with that, I reduced the classes, the food-related classes, from 35 to 30. And in places, it doesn't show much improvement, but I think that with the egocentric images will. And another thing I considered, but now I have discarded a little bit because I didn't have time, is learning features unsupervised, because I had to make a long report about unsupervised deep learning. And one of the things that they defended was that they could pre-train basically an autoencoder. They used autoencoders with a huge unlabeled dataset, and then perform a fine-tuning with the autoencoder and a classifier for a smaller labeled dataset and get better results than if you do train only with the labeled one. But I didn't have time to look at it deeply. And also the knowledge guided disambiguation, that was a paper that I presented in the reading group on the 24th of November. I don't expect you to remember it, but I was trying to reproduce the results and I was getting in trouble because it was a big work and I had to do things that go quite deeper into cafe, and it started getting quite complicated. But 2 days ago, they released the models already trained, so it is still on the table again because they gave me their work known, so I don't have to reproduce it, just to run it. And some results so far in places 365 is by fine-tuning this. You see that I get an accuracy of 50, almost 57% on food-related, 35 food-related classes versus not food-related, and a top 5 of 87%. And you see the confusion matrix here. You see that I am having trouble with one cluster called cafeteria, which is very, very heterogeneous, and I don't get to classify it very well. And well, with only food-related classes, which is FR35, I get a slightly better accuracy, but not much. So the problem here is not distinguished between food versus no food, but among the food-related categories. And I tested it on LGBTSER without training with egocentric images, and you see that more or less it tends to identify the images that are food-related, actually. Take into account that this has never seen an egocentric image, so everything having to do with occlusion or seeing roofs or floors and everything, that is one of the problems with egocentric images, is not aware of it. So it does not know nothing. I have to get better at this. I guess that with fine-tuning it will get a little bit better, at least. And another example here, I didn't put accuracy here. And more or less you see that it's learning, but I have to get better. And some challenges I'm facing here with places, especially food-related things, the intra-class variability, is that in the same class you can find images very heterogeneous. For instance, the class that we were unable to classify very well, that was this cafeteria, and you can see images that correspond to a cafeteria in a university, a restaurant, quite fancy ones, by the way, or a bar, a coffee shop. I don't know, very, very heterogeneous. I don't know if it is because different people labeled it or because of the ambiguity of the term, I don't know. But also have the problem of the interclass similarity. For instance, I have pizzeria and I have restaurant, and pizzeria is a restaurant. So they will be very, very similar. And I also said that the dataset is huge, but it's very unbalanced for food-related environments, obviously. So it's not so big as it looks like at first time. It is still very big and nice. But for eco places, I have the problem of lack of images. I have to gather them, most of them. I gathered a lot. I labeled many that you have. But there are some classes that are especially difficult. Some of them, because are unusual places, places that you don't go anywhere, every day, sorry. Or there are other places that are fast places, places where you spend a minute or two. For instance, a bakery shop. When you go buy bread, you spend like 2 minutes, 5 if there are people. And with the cameras, you get 10 photos most. And also I have the problem of the noisy images. And I notice this because I have trouble labeling sometimes, because I see an image that it's half covered with hair, that to me happened a lot, for instance, and I don't know where it is. And I have to infer it from the images before and images after. But I have also seen a lot of roofs and floors and walls, which is normal because with the egocentric image you see what you get and that's it. And this is something that we have to take into account. And well, my future is working on this to submit my master thesis to the 28th of April, then doing the presentation from the 8th to the 12th. I don't know the final date. And afterwards, I don't know, finishing the master's and don't know, get on with my life. And well, thank you for listening. That was all. And if you have any question or any suggestions, everything is welcome.
What is the part that you have more questions at this moment from your work?
Well, how to accelerate the weight regularization. For the weight regularization, I have to, for each iteration, get the weights on the convolution and the fully connected layers. I'm actually only getting the convolutional and apply my regularization to the gradient, and therefore update the weights that way. The thing is that I have to do an inner product, and from quite big matrices, and it is very slow. So this is slowing the training a lot, and a lot. Like it's not feasible to train a whole network with places with this speed. And I don't know how to accelerate this. I don't know if any of you have ever been in this situation and knows any tricks. I have searched on the internet, but I have to solve this because it's interesting, but not usable right now with this speed.
And do you have to necessarily do it on every iteration? Or you could do it every 100, for example?
So maybe what they proposed was do it in every iteration.
And you didn't compare?
No, but also it is very funny because we tested it with MNIST and CIFAR, which are smaller data sets. And for that, yes, for that it's feasible, but for places we didn't check. And also they did it on ResNet. They did it on ResNet and it was like, oh, it's nice because they have to do a lot of operations, they can do this fast, but they do it in a small data set. So it's not it is quite new, it is from the end of this year, the paper, I think, so there aren't any...
So maybe you could try to do it every 100 iterations, for example, check if it improves, and if it does, then you can keep lowering those numbers to do it every 10 iterations, so if you see that it works, maybe.
Yeah, I'll try that. Thank you.
because it is for the negative correlation. So that it means that, for example, you can check if there are no negative. So you can.
Of course, they put a filter, sort of
Yes.
a parameter that only regularizes the ones that are bigger than, but they are working with the whole matrix weight. So actually the operation is on it. So you can start filtering, but I don't know if it will be slower. And actually I was only doing with the convolutional because with the fully connected it is even bigger and it is even slower. Because I have a fully connected that have a matrix of 4,000 by 25,000 or something like that. And it gets a bit stuck there. So they showed the results with the convolutions only and with both, and they were a bit better with all, but not much.
I think that's true. So you have been problems doing the randomization of the features or of the weights?
The weights.
The weights.
And it has been a bit messy too because you cannot access easily the weights on Cafe. I had to implement a solver manually so I can handle it because from you can try to implement a layer, but from the layer you only get the activations, I think, not the weights. And I took a look at Keras too, but I am very new to it and I didn't find an easy way to get them.
Did you try to drop out?
They they proposed this and they said that it improved the results even that are already using Dropout. So they are not exclusive. You can use Dropout and this. And in the experiments they made, they showed that it was better. I cannot tell you that it will be better because I haven't tried it with my program. They tried it with NNIST and CIFAR, that are typical small datasets.
But in fact, what is the main benefit? It is faster? It should be faster or better?
Both. It converts faster. In the results, they have shown that it gets to a better accuracy in a better time.
Number of iterations.
In number of
But not
iterations, of
in
course, yeah.
Computational time.
No, computational time we have seen that, no.
Okay. This is a suggestion for you also for the master thesis, and also a suggestion for the rest of the people. When you do a presentation, it would be nice to give some more results so that the people understand you well. Because if you don't give some more details, it is very difficult for the people to perceive it and then to give you feedback. Right? So for your master thesis, it is important to explain it. It shouldn't be just blah, blah, blah.
Yeah.
But usually there should be a reasonable amount of formulas so that people can understand what exactly you're doing. So it is not only heuristic, but it is basic on some technical stuff. And in this way also the other people can learn. Right?
Okay.
And so this is important. You were mentioning about the unsupervised learning. So what did you think about? How can you use it?
I think that it sounded very nice, but I have never used anything unsupervised. I have never used an autoencoder, and I have never used a deep belief network, so it is totally new to me. And I see that there are many papers saying that it is very good and that it helps training with small label datasets, but I don't even know how to start. So I preferred to keep working on something I have already opened and I have like a direction to go, not starting from scratch in something new that I didn't even know if it was going to work or if I was going to understand it in a couple of weeks and get it going, or spend 3 months without getting results. That's from safety, basically.
And I was wondering, so now you have the different scenes. So have you thought about if you get from the different scenes, you apply some kind of object detection and then try to help with the labels of the objects in order to classify better the scene? Have you thought about this?
In monitoring disintegration, they use something similar, not exactly with object detection. They use sublabels learned from another net. For instance, they use sublabels learned from ImageNet. So that you can see that, for instance, the class kitchen usually has the sublabel of ImageNet of table, for instance. And they did that. And it was interesting, and you know that I tried to apply it, but I got it stuck because I had to train from all the whole pages dataset from scratch, and it was difficult. I had to use silence networks that were huge. I had to implement a new loss layer. I was new to that too, and it started getting quite difficult. And then we found out about the weight decorrelations, and we switched to that. But now they have released the models, and it's like it's still on the table again. Because it doesn't sound so difficult, they use a new type of loss for cafe, but they gave us the label already implemented and tested by them, and it is supposed to work. And I heard that they told me that you were talking last week about having different versions of cafe, and I would be interested in that because they have their own version, functional version of cafe. And if I could have two in the server, it would be nice because I wouldn't have to recompile the other version. And I know all of you.
Gabriel, do you know this? Who was discussing about this having different versions?
Pedro talked about the environment.
No, but it's different. So the thing is that they fork, I suppose that they fork the original cafe and they modified some things.
Yeah, but
And you want to merge your version
no,
to
yeah, I have a fork. They made it. They have this layer. They have an old version of cafe fork, and added this layer, and it is working. And we have tested it's working. And I could just clone this and execute this. But I need two different versions of cafe so they don't mess with with your work using the version you have. So,
No, I'm not sure, but it's about the efficiency. Because
I think
we install Cafe in Python and we also need the media driver and that stuff.
yeah, but I don't think that's a problem. I don't think that's a problem because you can install it and then add it to your path, to your environment path with another name and to another label. The problem is with the interfaces. With PyCafe and the MATLAB, I do not use MATLAB, but when you compile PyCafe, I don't know how to say this, compile this, but don't call it Cafe, call it Cafe 2 or Cafe Monasteries, I don't know. That is the thing.
I can help you if you want.
I am open to it, but I have to talk to you by Skype because I am leaving this weekend.
I see.
This afternoon?
Hmm?
Maybe we can speak this afternoon?
Yeah, I have to move and I haven't cleaned my house. I have everything messed up.
Okay.
But I haven't started really, so
Okay.
I have a lot of things to do and I don't know when I'm going to sleep.
Okay.
And I cannot sleep in the travel because I'm going to go by car driving me. So I can't sleep there.
Okay.
My next question, do you need MATLAB?
No, Python.
Just Python?
And actually, Python is not necessary because I can train directly on Kafka. And for the test, I can remove the layer that gives me conflicts. If I have the Kafka model, I think it's alright.
Okay, we can try.
But I don't want to break anything. Because every time I try to recompile Kafka in my laptop, I break it.
Yeah,
You know about this.
yeah, I know.
Okay, good. Do we have any questions? Okay, thank you. Thank you.
Se me olvida, lo siento.
Me he acordado ahora ya está.